Hello everyone. So in this video lecture, we will see the fundamental RC circuit, but little different orientation of the components R and C. Okay. The lectures we have covered till this point of time, where we are giving the input excitation at the one end of resistor, and we are taking the output across the capacitor. So that was the case of low pass filter, and here we are taking the output across the resistor. So there is only slight change. And according to this change, what is the analysis going to be there? So we have to discuss. Okay. So let I take this circuit first, where I am applying a step input. That's a 5 volt input. And here we are applying a pulse in the second circuit that we will discuss here or on the in the coming time. Okay. So what is happening here? The first thing is that at t equal to 0 negative, if I see what input we are applying, it's simply it is a 0 into be 0. Okay. So my circuit is at rest and output I am considering to be 0 because no current is flowing, everything is 0. So output I am considering to be 0. Now, what is happening at t equal to 0 positive? Because we know that at that time, just we are applying a sudden change in the input that we already discussed many times. So what is happening? Capacitor is to be shorted. Cap is shorted. So what is the circuit at this point of time? If my cap is shorted, this is the resistor, this is my output, and this is the 5 volt now. Okay. So this 5 volt is directly coming to the output, and the current in this capacitor, or I should say same current flowing through the resistor, that current IC or IR, they are same. What is the current? Current IC 0 positive, just at 0 positive. What is this? It is 5 by R. Okay. So this is the current. So what is going to happen if I talk about the slope? So what is going to be the slope of capacitor voltage? Slope equal to, or it will be this current at this time, or initial slope I should say. The initial slope, it should be 5 by R, the current time, so current divided by capacitor. So this is the initial slope. Then okay. So what it will do? Actually, the initial current is this. The initial current, as my initial current is 5 by R. So let's say this is a fixed current that is charging my capacitor. So from this point, we can say V out is also defined. So what is my V out? V out is nothing but 5 volt. Initially, V out 0 positive is 5 volt. Let's say this current is constant for some time. Just I am saying this thing to analyze the circuit. If I'm considering this current to be constant, then what should be the capacitor voltage? The capacitor voltage should be that it should be function of time. If the current is constant, then it usually comes 5 by RC to T. Okay, it comes like that. So what I mean to say, this capacitor voltage is like increasing. Initially, what is going to happen? Actually, this node came at 0. So initial the voltage across the capacitor is 0. Now it started charging because the current is started flowing. That current is 5 by R. So if the capacitor will start charging, it means it's the some voltage should come across it. Okay. So what is the voltage? The voltage is following this equation 5 by RC into T. That is general equation that we write. General equation for the voltage we write 1 upon C IT. From this, our result is coming. I am considering the current is constant. But what will happen? Once the capacitor is charged to some value, let's say at t equal to t naught, which is a time instant greater than 0. Okay, in some time instant, I am not exactly telling about what is the time. But at that instant, if I say my capacitor is charged to, if I say my capacitor is charged to some voltage called 1 volt. Okay, so if capacitor is charged to 1 volt, then what will happen? What will be the now new current? If I say about the current, what is the current? Actually, current at Z I C T positive, because IC equal to IR. So what is this current? The current is going to be, because input voltage, the current actual definition of this current is what? Input current, sorry, input voltage, that is means input voltage minus capacitor voltage, which is nothing but your output voltage defined by or divided by resistor. This is the actual current at any instant of time. So this current is a general equation for the circuit. For this circuit means IC, or I should say IR. General expression of this current is V out by R. And V out we know it is nothing but V in minus capacitor voltage divided by, okay. So the same thing I am writing here. So what to speak of V in at t equal to t naught positive, it is a 5 volt, minus what to speak of Vc, and Vc we have defined the 1 volt here, 1 volt, okay, divided by R. So actually this current now decreased to 4 by R. So what is the slope of capacitor voltage at this point? Slope of capacitor voltage, slope, or I should say, yeah, slope of capacitor voltage at this instance comes to be like 4 by RC. Okay, so this is the new slope. So what we can say, this analysis we have seen, if I talk about the capacitor voltage at a different instant, let I should say the third instant, which is t equal to t1, which is greater than t naught. At this instant, let's say my cap is charged to VC T1 or T1 positive. Let my capacitor is charged to 2 volt. Okay. So what is the current now? The current across the capacitor at this time instant is to be input voltage, which is my 5 volt, minus this capacitor voltage. This become my output voltage divided by R. So it becomes 3 by R. So slowly, same thing we are observing here also. Whether we are taking the output across the resistor, first we are calculating the voltage or the currents and the slopes at every instant of time for the capacitor. Okay. So my output, actual output, I am taking across the resistor, but whatever analysis we are doing through the capacitor, so that it can be easily understood that what the output is going to be. So the slope at this instant is 3 by RC. Okay, so this is the slope. So if I plot the capacitor voltage that we have plotted many times, this is time instant. So initially the slope was high, that is a 5 by RC, that was 5 by RC initial slope, and after the T naught instant it is reduced to 4 by RC, and after this T1 instant it is reduced to 3 by RC, and so on. So anyway, this is nothing but what we have plotted many times. It is simple exponential increase. When these time instants are very close to each other, what will be the final output voltage of the capacitor? Okay, so capacitor will finally reach to what value? When my output, because output is slowly increasing. If output is slowly increasing, then what is happening here? Or output, what is the initial value of the output? So initial output is 5 volt. No, output is not increasing. Actually, output is decreasing here. So when the capacitor was charged to 0 volt, the output was 5 volt. When capacitor is slowly increasing, the output is going down to be 0 slowly. So what is the maximum voltage that capacitor can get? It is the 5 volt or the input voltage only. Okay. At some time, it can be the after some time, maximum voltage of the capacitor can be 5 volt. The capacitor will follow its means same equation or same exponential nature that we have seen many times. Okay, so if this is the capacitor voltage nature, then what is output voltage? Simple, we know the output voltage is what? Input voltage minus capacitor voltage. This is the output voltage. So we can write initially what was the output? Initially it was 0, and after that we have considered a capacitor charge to 1 volt. Sorry, initially it was 5 volt. Capacitor was 0, but output was 5 volt. Okay, yeah. So initially the output was 5 volt because capacitor was charged to 0. And after that, my capacitor reached 1 volt, so it slowly reached 4 volt, slowly reached 3 volt, and slowly it follows to 0 volt. Okay, so output is nothing but doing what? That nature is easily visible. That is my V out actually. So initially it was 5 volt. After that, it is following the exponential decay. Okay, so this is the actual nature of the output we are getting. And so current is not a different thing. Current is whatever it is IC or IR, the same thing. It is nothing but V out by R. So if we have V out, the same nature of this current can also be derived. This is IC or IR. The initial value is 5 by R, and after that is decaying to 0. Okay. So this is the analysis of this circuit, the fundamental circuit and the basic analysis. If we go for the second circuit, which is nothing but a pulse we are applying, and okay, so if we going to second circuit, what is this? We are applying a pulse. Which is nothing but 0 and T naught. This is my 5 volt. Same circuit. So time constant for this circuit as well is no more different from the RC because we are only taking 1 R and 1C for last many videos. Okay. So for this circuit, we can see if I'm considering T naught much greater than RC, and you can consider T naught much lesser than RC. So for these two cases, the circuit can be analyzed, but I'll give the idea here. The exact analysis you have to do at means as a homework, or if I'll get the time, I'll do the complete analysis. So do what simply T equal to 0 positive. I'll see my what do I say cap to be shorted. So we see 0 positive to be 0 volt. I'm not considering any initial charge. We will slowly take the circuits with the initial charges or on the capacitors also. But as of now, I'm not considering any initial charge on capacitor. Okay, so this is the voltage. And what will happen? Let I'm considering my T naught is much greater than RC. If my T naught is much greater than RC, simply I'm giving a lot of time to charge the capacitor. Okay, capacitor is getting a lot of time. Capacitor is getting a lot of time to charge. Okay, if capacitor is getting a lot of time to charge, the same analysis will be like that. Whatever we have done till this point of time. So I can directly draw the output. If I talk about the V out, what will happen? It will discharge to 0. Okay, but there is a catch. At this point is T naught. This is the output. They started from the 5 volt. Output like that. Because T naught is much greater than the RC, my capacitor is completely charged or output is reached to 0. So for this, my capacitor is reached to 5 volt around the T naught. Or it has reached to 0, means 5 volt. Now, if my excitation is removed, so I should consider the second case. So what is happening? A T equal to T naught positive, because T naught is much greater than, so my capacitor is already charged to 5 volt. Okay, so now this thing, the excitation is to be 0. So this is my R, this is our V out, and V out is 0 at this point. Okay, so what is going to be there? Now excitation is removed. As excitation is removed, the circuit is no more like it is simple. This capacitor is here, 5 volts. This is my resistor, capacitor, V out. So what we are observing now, the capacitor voltage is only the output voltage. From here, what we can see, V out is nothing but equal to minus of VC, because actually we are considering this direction for the VC plus there. So this was the my VC. So plus minus. Now, if this capacitor is like this input side is shorted because now excitation is not present, so the output voltage is exactly the minus times of the BC, because the initial expression was the means for the output was what? Initial expression what we were writing, it was V1 minus Vc. Now for t greater than t naught, my V in to be 0 again. So why V out to be minus Vc. So this thing we can see from the equation, also directly from the diagram we can see it. Okay. So now what is the V out? V out T naught positive to be minus 5 volt, because capacitor reached to 5 volt already, because T naught is much greater than the, because this is the case we are considering T naught is much greater than the RC. Okay. So now what should happen? Output is minus 5. So current is what? Actually, we're considering the direction of current like this. Still, I will be continue with this direction. So this is my IC equal to IR, which is nothing but it comes to be minus 5 by R at this instant. Okay. So what is the capacitor means capacitor slope, or if I say the what is the capacitor voltage at t equal to 0 positive, is nothing but means what I should say 5 volt plus 5 volt. And that is as of now, because we have to consider the direction of capacitor voltage from left to right. So it is still means 5 volt. From here we have drawn what is the V out? V out is nothing but minus 5 volt. So how capacitor will discharge? This is the point. So I observed here I see T0 positive is what? Minus 5 by R. So what is the slope? Slope of capacitor voltage to be slope of capacitor voltage minus 5 by RC. It simply means whatever value the capacitor has reached, it has to decrease with this initial slope. This is the initial slope. Initial slope at t equal to t naught. Okay, so I have seen my capacitor was reached to 5 volt like this. So let this is my t naught instant. This is my t naught instant. T. So after that, the initial with the initial slope of this that I call again minus 5 by RC, the initial slope, it will decrease. Okay, it will decrease and it will reach to 0. Okay, so this is happening. You will see slowly the capacitor is discharging, so the amount of discharging current is also discharging. Let's say at some instant, just I am telling here, let's say at some instant T naught plus some Tx. What is happening? My capacitor voltage is now reduced to 4 volt. So what to speak of output voltage? Output voltage is equal to minus 4 volt. So what is the current? Current at this instant of time, or IC or IR. What is this current? Current is minus 4 by R. So slope of capacitor voltage is minus 4 by RC. So we can see the slope is decreasing, simply means the discharging is happening like this, whatever the diagram I have drawn on the top. Okay. So with this nature, this is the capacitor voltage. Exact our target is to draw the output voltage. So what we have seen, the output was my 5 volt, and we have seen it has to be decreased to 0. This was 5 volt. This point is your T naught, or I should draw T naught above, because we have to see the exact nature of the plot. Okay, so this is my T naught. So what we have seen at T naught plus T equal to T, or T greater than T naught, what will happen here? This is the reason I am telling. So we are seeing that output is suddenly going to minus 5, because my capacitor's one end is shorted. So the entire the capacitor voltage is coming as a output voltage, but with a negative sign. Okay, so the entire voltage of capacitor is coming as a output voltage. And slowly we are seeing that as capacitor voltage is reducing, output is also reducing. Slowly it reaches to zero again. So this is the exact nature of output. Now we can extend our discussion. Okay, so output is clear. Now IC or IR is also clear. This is nothing but V out by R. Okay. So now we can extend our discussion, which is a part of our homework. Just take a complete pulse and draw. This is my 5 volt. This is T by 2. This is T 0. Okay. So now same circuit. See, one can try for this. The cases are as usual. T is much greater than RC. T is much greater than or lesser than RC. And in the previous this circuit also the case T is much lesser than the RC is remained. Okay. So this I am leaving as a part of homework. And if someone is not able to solve, I'll discuss these all things in the next video where we will see both cases for this circuit and the left circuit, the case for this circuit, whatever we discussed in this. So I think this is enough for the discussion. We simply changed the position of capacitor and resistor. Same, everything is same. Just I want to tell that how to analyze a circuit with the different means the currents at different time instants, and from that current, what is the capacitor voltage. So as we change the position of capacitor and resistor, we want the output, which is nothing but a voltage across the resistor, but we are going through the capacitor so that the analysis can be easily done, whatever we have done previously. Okay, so there is no change going to happen for this analysis and that analysis we have done till the lecture 9, first nine lectures. Okay, so I think this is enough for this video. Thank you.